Alright, so today we are going to be starting chapter 1, which is titled Functions and Graphs. So most of what we are going to do in chapter 1 is going to be a review of classes you have had in the past. We just want to make sure you are good with everything before we actually start with the new Calculus 1 stuff. And so that's what we are going to be doing for the first 2 weeks. So first off, we're starting with section 1.1, which is a review of functions. Let's first define what a function is. So this is going to be a definition. A function consists of a set of inputs, a set of outputs, and a rule for assigning each input to exactly one output. The set of inputs is called the domain, and the set of outputs is called the range. So pretty much what this means is that it's going to be a rule that is going to relate everything in the domain to exactly one thing in the range, okay? And that's a big point, is that I'm only going to want everything to map to only one thing in the range, okay? So let's look at an example of what I mean by that. So this is going to be a visual you are going to see in the textbook. I'm just going to draw it out, kind of explain it. So the textbook likes using figures like this. So they're going to have like a set over here, which they call the domain, and it's just going to have a few things in it. I'll just use the numbers 1, 2, 3, and 4. And then there's going to be another set over here called the range. And I'm just going to fill it with the numbers 2, 4, and 6. Okay. So what it is there's going to be some kind of rule that is going to say everything in the first set over here is going to relate to exactly one thing over here. Okay. So like I could say the number 1 relates to the number 4 in the range. 1 relates to 4. Let's let 2 relate to the number 6. Let's let 3 relate to the number 2. And let's let 4 relate to the number 4. That is a function, because everything over here relates to exactly one thing over there. Now notice there are 2 things relating to 4 right here, right? That's okay, as long as everything over here in the first set relates to only 1. So like by that, I mean there's only one line from the 1 to something else, right? There's only one line over there. So then like for 2 right here, 2 only goes to one thing over there. And so that counts. 3, 2, right? 3 goes to one thing over there. 4 goes to one thing over there. So I don't care if there's something over here coming from 2 things. That's fine. I don't care about that. It's just that over here, there's only one line. Okay, 1 goes to 4, 2 goes to 6, 3 goes to 2, and 4 goes to 4. Okay, that's what we mean. With math, though, we like it in terms of an equation, okay? That's what we really like, is whenever the rule, what's happening in between right here, is in the form of an equation. And for that, we use what's called function notation. And this is used when a function is in the form of an equation, which is what we really like for this class, okay? So normally what I will see is something like f parentheses with an x, okay? And what this means, how I can read this, is actually f of the x, okay? F of x. The f right here is just the name. So the f is the name of the function. And whatever is inside of here is what I'm actually going to plug in, okay? So the x is what I plug in. So by that, what I mean is, let's say I had f of x equals 2x minus 1, okay? The f right here is the name of it, so that I know this is the function f. That's what that means, okay? And this part right here means I'm going to plug in the values for x. So if I wanted to do f of 2, I'm plugging in 2 for x. That's what that means, okay? So let's look at some examples of using function notation. We're going to use this a lot throughout this whole class and any other math class you ever take in your life. Function notation is used a lot. All right, let's look at an example. Let's let f of x be equal to the function 3x squared plus 2x minus 1. Okay, 3x squared plus 2x minus 1. Again, what this means is I'm going to plug in the values for x. Okay, everywhere I see an x, I'm going to plug something in there. So the first thing I want to do is let's evaluate f of negative 2. Okay. So what that means is I'm going to plug in the negative 2 everywhere I see an x. Okay. So f of negative 2 is going to be 3 times negative 2 squared plus 2 times negative 2 minus 1. And then I'm just going to work that out. Okay. So the first things first, right here, I'm going to do the negative 2 squared. Be careful here. I have seen a lot of times some people try to multiply by the 3 first, and so then they would do 3 times that, which would be negative 6 squared. That is not right, okay? Because the only thing being squared is the value right here, okay? So don't do that. Square first. So negative 2 squared is positive 4, so that becomes 3 times 4. Now I'm going to multiply these. 2 times the negative 2 is negative 4, and then minus 1. Work that out more. 3 times 4 is 12, so that's 12 minus 4 minus 1. 12 minus 4 is 8, minus 1 is 7. So that's what I get there. Again, all I did was just plug this in for x. Going on to part B, let's evaluate something a little bit weird, because a lot of times we're going to see some weird stuff in this class. And by weird, I mean a number you don't normally think about, okay? So like for this one, they asked for f of the square root of 2. So what I mean by like weird here is that you normally don't think about plugging in a square root, right? But sometimes you are going to have to do that in this class. And so that's why I want to do those here. So plugging in the square root of 2, f of square root of 2 equals 3 times the square root of 2 squared plus 2 square roots of 2 minus 1. Square root of 2 squared. So think about it. If I'm squaring a square root, that basically undoes the square root, right? So the square root of 2 squared is just 2. So that's going to be 3 times 2. 2 times the square root of 2. There's nothing I can really do there, right? There's no other way I can rewrite that, and so that's going to just stay 2 square roots of 2. That's why I wanted to do one with the square root, was to show you that sometimes you are going to have a term with just a square root, right? So 2 square root of 2. Then, of course, the minus 1. Now I'm going to work this out as much as I can. 3 times 2 is 6. So that's 6 plus 2 square roots of 2 minus 1. Now I need to combine whatever like terms I have. So notice here I have a 6 and then a minus 1. 6 minus 1 is 5. So that's 5 plus 2 square roots of 2. One big point I want to make is that if you ever get something with the square root, leave it as a square root, okay? Or if you ever have one with like a pi, then just leave pi there. Or if you ever anything that's kind of strange, right? Just leave it there. So like here, I'm going to leave this to square root of 2. Okay, leave it there. Don't try to like round it. Don't try to do all of that stuff. Just leave it to square root of 2. Let's look at some more examples. This is a good one, something we are going to do in this class a lot. A lot. This is part C, and this wants us to find f of x plus h. X plus h. Okay, so remember what function notation tells us, right? Remember, like right here, what I did was I plugged this in for x. So everywhere I saw an x, I put that in there, right? I plugged it in here, and all that stuff, right? I'm doing the exact same thing here, even though it looks a little strange, okay? It's the same thing. Everywhere I see an x, I'm going to take that out and replace it with x plus h, okay? So how this is going to look, f of x plus h is going to be 3 times x plus h squared plus 2 times x plus h minus 1. Again, what I did was everywhere I saw an x, I took it out and I replaced it with x plus h. What I see a lot of times is some people will just see this and then say, oh, it's the same thing, I just need to put plus h. And that is not right, okay? You need to replace it. Everywhere I see an x, replace it with x plus h, like I did right here, right? X became x plus h, and the same thing right here. And so now I just need to, exactly like we have done, work this out as much as I can. First things first is do x plus h squared. Remember, when I do x plus h squared, I can't just square both of these, right? I have to actually multiply it out twice. So x plus h times x plus h. X times x is x squared. X times h is xh. H times x is also xh. H times h is h squared. Combine like terms, and you have x squared. There's 2 of these. So plus 2xh plus h squared. So that's what x plus h squared is. So this gives me 3 times x squared plus 2xh plus h squared. Distribute the 2 right here. We don't need that anymore. Plus 2x plus 2h, again because I distributed this 2, minus 1. And then now we've just got to work this out as much as I can. So distribute the 3 right here. 3x squared. 3 times 2 is 6, so plus 6xh. And then 3 times h squared. No other like terms over here, so those are all just going to stay the same thing. And then now I'm going to look at this and I'm going to see, okay, are there any like terms here? And there's not, right? Because I have x squared, there's no other ones of those over here. Xh, no more of those. H squared, there's no more of those. No more of the x, no more of h. So that's it. That's as far as we can take that one. So my main point here is just anytime I see something like this, whatever is inside of the parentheses is what I'm going to plug in for x. So anywhere I see an x, I'm going to replace it with whatever is inside of it. Let's look at another example. This time it's going to be a different function. let's let f of x be equal to x squared minus 3x plus 5. And the first thing we're going to do is we're going to evaluate f of 1. F of 1. So like we said, what this means is everywhere inside of here I see an x, I'm going to take x out and replace it with a 1. Okay? So f of 1 is really 1 squared minus 3 times 1 plus 5. Again, because all that I did was I took out every single x right there and I replaced it with a 1. So now I just work this out. 1 squared is 1. 3 times 1 is 3, so minus 3 plus 5. 1 minus 3 is negative 2, plus 5 is going to be 3. Why does that seem? Yeah, right, 3. I don't know why that seemed wrong for some reason. So what you get is 3. One more just to make sure we are good. The one thing I want to say is, since this is not a live thing, since this is a recording, remember you can hit pause or rewind or do whatever you got to do. Last one. Again, let's do f of x plus h. The reason I want to do this one a whole lot is because we are going to use this a lot, especially in chapter 3. And so that's why I want to make sure we do this. Okay. All right, so like I said, what I want to do here is anywhere I see an x, I want to take x out and replace it with x plus h. So f of x plus h, I had x squared, and so now it's x plus h squared. I had minus 3x, and so now it's minus 3 times x plus h. And then, of course, the plus 5 just stays plus 5. And then I'll work that out. We already did x plus h squared. What we said there was that I've got to multiply it out twice, right? We did that a while ago. We did that, and we got x squared plus 2xh plus h squared. Distribute the negative 3, so negative 3x minus 3h, and then plus 5. There are no like terms, and so I know I can stop right there. So that is function notation. Again, it is used whenever it is in terms of an equation. All right, so one of the cool things we can do whenever it is in function notation is I can actually find what the domain and the range are. Okay, remember the domain is everything I'm going to plug in. So for this case, that's everything for the x, right? Because I plug in values for the x. The range is everything I get back, right? And so this is going to be everything I get after I plug in the x. So let's look at how I can find what the domain and the range are, okay? I do so using domain restrictions. And right now we have 2. We are going to learn a third in section 1.5, I think it is. But for now, let's just do these main 2. The first domain restriction, again, what this is it's going to tell us what x cannot be. What are the values I cannot plug in, okay? That's what I'm going to find right here. I get domain restrictions if there's a square root, okay? If you see a square root, what this means is that the inside of the square root cannot be negative, which means it has to be greater than or equal to 0. Again, that is the stuff inside of the square root. So if you see a square root, we know that much, okay? The inside of it cannot be a negative. The other domain restriction is if I have a fraction. In that case, the denominator cannot be 0. And so how I find the domain and the the range is I'm going to see, is there a restriction here? If so, then we need to find what x cannot be. Okay, that will tell us what the domain is. So let's do some examples of that. For right now, we are only going to focus on the domain. We will learn how to find the range in section 1 point, I think it's 4. And so hang on until then, okay? So let's find the domain of each of the following. The first one's going to be the function f of x equals x minus 4 squared plus 5. We're going to find what the domain is. So to do this, what I've got to see first is there a restriction on what my domain can be, okay? So the first one we said was that if I have a square root, I'm going to look right here and I can see there is no square roots here, so I do not need to worry about that one, okay? So again, the first domain restriction we have right here is if it has a square root. There's not one there, right? And so I am good there. Restriction number 2 is if I have a fraction. So I'm going to look and I can see I don't. So what this means is that there are no domain restrictions, which means, if I can spell restrictions, which means my domain, you can write this a lot of ways. You can write the domain as all real numbers. You can write it as the interval negative infinity to positive infinity. Or you can write it as a set. You can just put it's the set of all x such that x is real. It doesn't matter. You can write it any of these 3 ways right here. Any of those are the right way. The textbook, I believe, does it as a set, but I mean, I write it a lot of times like this just because it's less you've got to write down. Either way, these are all the right way. Okay. So let's look at one where they actually do have a domain restriction. Let's look at one like that. That's going to be the function f of x equals the square root of 3x plus 2. So let's look there. F of x equals the square root of 3x plus 2. So like I said, what I do is I'm going to see, is there a domain restriction here, okay? As I can see, I have a square root, which I don't really like, right? We said when there is a square root, we do have to kind of restrict what x can be, okay? So what we said about square roots was that the inside of it, in this case 3x plus 2, has to be greater than or equal to 0, right? That's what we said. Let me find that board where I wrote that. Here it is, square root. The inside of it has to be greater than or equal to 0. So that's what I did. Okay. Again, I did that because I have a square root. All right, so what I've got to do is I've got to solve this. So let's subtract 2 on both sides. So 3x has to be greater than or equal to negative 2, and then divide that by 3. So x has to be greater than or equal to negative 2/3. So that's what I know about what x can be, right? X has to be greater than or equal to 2/3. So there are several ways I can write this. The first way is I can write it as a set. It can be the set of all x such that x is greater than or equal to negative 2/3. You can write it just like that, and that'll work. Or a lot of times I see people want to write it like this. Since it has to be greater than, I know the first thing it can be is negative 2/3. So I'm going to do bracket negative 2/3, and it can be anything else. So either way is fine. Again, I believe the textbook does it like this. I prefer this way just because it's less stuff that I got it right. But it doesn't matter. They are both right. So the key thing here, since I had a square root, I know the stuff inside of it has to be greater than or equal to 0. So that's what I did. One more example where there is a restriction. Let's do the function f of x equals 3 over x minus 2. 3 over x minus 2. Okay, so I'm going to look here and I want to know, is there a restriction here? And using my 2, I see I have a fraction, right? I can see that right here. So what I know from that is the denominator cannot be 0. So in this case, that means x minus 2 cannot be equal to 0. That's what I know. Again, because that's what I wrote down on my restriction. Okay. So solving that for x, I can add 2, and that tells me x cannot be equal to 2. So it can be anything else. It just cannot be 2. It can be stuff that's smaller than 2, or stuff that is more than 2, right? It just cannot be 2. So the two ways you can write that, you can write it as the set of all x such that x is not equal to 2. Again, that I believe is how the textbook will write that. Or I prefer it like this, negative infinity to 2, but it can't be 2, right? So it's going to be parentheses, union with everything greater than 2, right? It can be anything, it just cannot be 2. And so if I write it like this, this says it's everything except for this 2. I took out 2, right? Again, either way, you are fine. Write it however you want to. They're both right. Okay. Another key part of a function we are going to need. Let's define that right here. Definition. The zeros, or sometimes called x-intercepts, of a function are the values of x that make y equal to 0. So the zeros are the values of x in which y is equal to 0. On the other hand, the y-intercept is the value of y that makes x equal to 0. These are terms I guarantee you have heard at some point in time. We are going to use these a lot here, especially in chapter 4 when we draw a whole bunch of graphs. Okay, we're going to do that. So let's practice finding some of these things. Sorry, I'm getting another board. Example. Find the zeros and the y-intercept for each of the following. first function we're going to do is the function f of x equals negative 4x plus 2. Negative 4x plus 2. First thing we are going to find is the zeros. Remember what we said on the last board was that is where y is equal to 0, right? So what I'm going to do is I'm going to plug in a 0 for the y, which in that case is the f of x. Plug in a 0 there, and I want to solve it for y. Or sorry, for x. We're going to solve this for x. Okay, so subtract 2. Negative 2 equals negative 4x, and then divide it by the negative 4. So we're going to divide this by negative 4. Negative 2 divided by the negative 4 is going to give us positive 1/2. So that happens at x equals to 1/2. Okay, again, all that I did there was I plugged in 0 for the y, which in this case is f of x. Plug 0 into there and solve it for x. The next one we are going to do, oh, I forgot about the y-intercept. Remember, that's where x is equal to 0. So for this one, I'm going to plug in a 0 for the x. So y equals negative 4 times 0 plus 2, and I've got to solve that for the y. So multiply this out, and you get 0. So y equals 0 plus 2. 0 plus 2 is just 2. So y equals 2. Easy enough. Let's do another example of that. We're going to do the same thing, but this time the function is going to be f of x equals square root of x plus 3 plus 1. Square root of x plus 3 plus 1. So the first one we're going to find is the zeros. Remember, that's where y is equal to 0. So we're going to plug in a 0 for the y. 0 equals the square root of x plus 3 plus 1. Solve that by subtracting 1. Negative 1 equals the square root of x plus 3. Since I have a square root, I get rid of that by squaring it. Square both sides. The negative 1 squared is just going to be positive 1. So 1 equals x plus 3. And then just subtract 3. So 1 minus 3 is negative 2. So it happens that x equals to the negative 2. Then we're going to do the same thing to find the y. Just let x be equal to 0 and solve it for y. X equals 0. So we have y equals the square root of 0 plus 3 plus 1. 0 plus 3 is just 3. So that's the square root of 3 plus 1. Remember, I said if we ever have a square root, just leave it as a square root. So that's all that I got. Square root of 3 plus 1. Again, this is a skill we are going to need whenever we draw the graphs in Chapter 4. Another cool thing we can do whenever we are in function notation is combine several functions. So that's what we are going to do. This is all about combining functions. And this is basically just like a notation thing. It's not too bad. If you ever see a function with the name f plus g, so f plus g of x, what that means is I'm going to do f of x and just add it to the g. So if you see a plus, do plus. That's pretty much it. Same thing if you see f minus g of x, you're going to subtract them. Same thing if you see f times g, you're going to do f of x times g of x. And then also if you see f divided by g, then of course you're just going to do f of x divided by g of x. But the main thing right here, g of x cannot be equal to 0 because I am dividing by that thing. So that's the only rule there. And then our last way is if you see f open dot g. What this means is f composed with g. If you see that, what that means is I want to do f of g of x. So what this means is I'm actually going to plug in g of x into the function for f. Okay? We are going to do some examples of that. Actually, of all of those, but you will see what this means. Example. We're going to let f of x be equal to 2x minus 3. And we're going to let g of x be equal to x squared minus 1. And we are going to do a few things with that. The first thing is we're going to find what f plus g of x is. So like we said, all that I've got to do whenever I do f plus g of x is add f of x plus g of x. So for this case, that's f of x, which is 2x minus 3, plus g of x, which we set up here is x squared minus 1. Combine like terms there. The only x squared term I have is x squared. And then the only x term I have is 2x, so that's going to just stay 2x. But then right here I have minus 3, minus 1, so that's minus 4. And that's it. Again, I just did f of x, which they gave us right here, plus g of x, which they said right here. So just add them up, this plus that. On the same note, f minus g of x, all that we do is subtract them. So the first one, f of x, is 2x minus 3. And then we are going to subtract all of this stuff right here, which means I'm going to subtract x squared, so minus x squared. But then I'm going to subtract negative 1, which is the same as saying plus 1. Again, since we are subtracting it, I've got to make this to every single term, right? So minus x squared, and then that makes this plus 1. Combine like terms there. The only x squared term I have is negative x squared. I only have one of these, so that's just going to be plus 2x. And then now I have minus 3 plus 1, which gives you minus 2. So just subtract them. We can do some more with this. Let's combine these another way. Let's do f times g of x. Okay. Remember, when I do that, all I do is f of x times g of x. So that means I'm just doing, that was 2x minus 3. So 2x minus 3 times, and then g of x was x squared minus 1. And so now let's work that out. So what I do is every term in the first part times every term over here. So 2x times x squared is 2x cubed. 2x times the minus 1 is minus 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times the negative 1 is positive 3. And then as I can see there are no like terms, and so I can just leave it like that. Or if you are like me and you want it written a certain way, you can do the 3 first, so 2x to the third, and then do the squared term, and then the x term, and then the constant. Either way, it doesn't matter. I just like it like that. And then the last way we can, or sorry, there are actually two more ways. We can actually divide them. F divided by g of x. Remember, all I do there is divide them. So f divided by g of x, we just do f of x divided by g of x. We said this first one was 2x minus 3, so that's 2x minus 3. G of x was x squared minus 1. So I look and see, is there any other way I can read like that? And there's not, so that can just stay like that. Dividing them just like that. The last thing I want to make sure we can do with this stuff is I want to make sure we can compose them. So let's do f composed with g first. Oh, let me erase all that. So this should be part E. F composed with g of x. Remember what that means. We said this means f of g of x, which means I'm plugging g of x into the function for f, right? Because we said g of x was x squared minus 1. So that's f of x squared minus 1. So everywhere I see an x, I'm going to take it out and replace it with x squared minus 1. So what that becomes is, because we said f of x was this right here, right? So everywhere I see the x, I'm going to take it out and replace it with x squared minus 1. So that's going to be 2 times x squared minus 1 minus 3. Again, because I just took this out and replaced it with x squared minus 1. Just plugged it in. So now let's simplify that. I can do so by distributing the 2. So 2x squared minus 2 minus 3. Combine like terms, negative 2 minus 3 is negative 5. So 2x squared minus 5. Again, so what I did was I plugged the function g into the function for f. And I plugged it in. Going backwards, I can also do g composed with f of x. That's g of f of x. So we already know f of x is 2x minus 3. So that's g of 2x minus 3. So everywhere in g I see it, I'm going to take out the x and replace it with 2x minus 3. I'm going to plug it in. So since it's x squared minus 1, now it's going to be 2x minus 3 squared minus 1. So now let's work that out. 2x minus 3 squared. Remember, we have to multiply it twice because it's squared. 2x times 2x is 4x squared. 2x times the negative 3 is negative 6x. Negative 3 times 2x is also negative 6x. Negative 3 times the negative 3 is positive 9. Combine like terms. 4x squared minus 12x plus 9. So that's going to become 4x squared minus 12x plus 9 minus 1. Combine 9 minus 1, and that gives you 8. So 4x squared minus 12x plus 8. So again, what this means is I'm plugging the f into the g. So I plugged in the function f, and I plugged it in for x inside of g. We are going to use that a lot in chapter 3 too. Alright, we only have one thing left to talk about in section 1.1, and that is even and odd. Even and odd. This is going to help us out a lot throughout this class. So let's define what I mean by even and odd. Definition. If f of x is equal to f of negative x. So if I change the sign for the x and it doesn't change what f is, okay? Again, if I change the sign for the x and it does not change what f is. If that happens, then f is an even function and is symmetric over the y-axis. Now, if f of negative x is equal to negative f of x, so then what this means is when I change the sign for the x, it will also change the sign for the f. If that happens, this should say then f is an odd function and is symmetric over the origin. So how I check and see which one it will be is I'm going to actually plug in minus x and see if my sign stays the same or changes. Okay, that's what I'm going to do. Plug in the negative x and see does my sign change or stay the same. So let's do some examples of that. Example. Determine if each of the following is even, odd, or neither. The first function we're going to do is f of x equals negative 5x to the fourth plus 7x squared minus 2. Okay, so what I said I want to do is I want to plug in negative x and see what that does to the sign of the whole thing. Okay, that's what I want to know. So plugging in negative x, that's going to be negative 5 times negative x to the fourth plus 7 times negative x squared minus 2. And I want to work this out and see what happens, okay? So negative x to the fourth. Let's see what that is, okay? I'll write it down here. Negative x to the fourth is negative x times negative x times negative x times negative x, right? 4 times. Negative 4 times, negative times the negative, doing that 4 times would give me a positive, right? So that's going to be positive, and then x times x times x times x is x to the fourth. So negative x to the fourth is the same as positive x to the fourth. So I can actually rewrite this as just leaving this as the x. So negative 5x to the fourth. Again, I can do that because doing this 4 times gives me positive x to the fourth. Same thing right here. If I do negative x squared, that's negative x times negative x, which gives me positive x times x is x squared. So I can just leave this as x squared. And then there's no change over here, so that's going to stay negative 2. So notice what happened right here. When I changed the sign for the x, it did not change it at all, right? Everything is the same. Every single sign, everything is the same as it already was. So since there was no change, this is even. Again, because there was no change at all. Let's do some more. Seeing what happens. Let's do f of x equals 3x over x squared plus 1. Let's see what happens there. So again, I'm going to change the sign for the x, so f of negative x. So that's going to be 3 times negative x over negative x squared plus 1. And let's work that out and see what happens there. Okay. 3 times the negative x is negative 3x over, we already said negative x squared is the same as just doing positive x squared because it's squared, so that's negative x times negative x, which gives me positive x squared, and then plus 1. So let's see what happened right here, okay? The only sign that changed was on the top part, right? But let's see what happens. I can write that out front, and I can see what happened was I changed my sign for the whole thing, right? This is negative what I had to start with, f of x. So because of that, this will be odd. Again, because my sign changed for the whole thing. So it's odd. Let's do one more example. This function is going to be f of x equals 2x to the 5th minus 4x plus 5. Let's see what happens there. So again, change our sign for x. So it's going to be 2 times negative x to the 5th minus 4 times negative x plus 5. And let's see what happens there, okay? Let's see what happens when I do negative x to the 5th. That's negative x times negative x times negative x times negative x times negative x. Negative 5 times is going to make this negative, and then x 5 times is x to the 5th. So what this means is the minus sign inside of here might as well be brought out to the front. That's what that means right here. So what that means is instead of having positive 2, I can make this negative 2 x to the 5th. Again, I can change that sign right here. Because of this right here where I saw that, I can bring it out to the front. Same thing right here, negative 4 times the negative x is going to make it positive 4x. And then I still have plus 5. So let's see what happened with this one, okay? I know it's not even because in order to do that, it must have stayed the same, right? Which it did not, because I can see my sign changed right here and it changed right here. But it is also not odd because in order for it to be odd, it must change everywhere, right? It changed here and it changed here, but my sign did not change right here. It's still plus 5, plus 5. So because of that, it is not an odd. Therefore, this is neither even nor odd. All right, so that is the end of what we are going to do in section 1.1. If any of that did not make sense at all, please let me know. I will be happy to help out. Go back and like rewatch stuff or rewind or do whatever you've got to do, but I am happy to help out, okay? So you can now either move on to section 1.2 or rewatch this if that'll help.